Today we'll be looking at page 34, question number 2. Over a 15-minute period, a truck travels on a road with many turns. The truck's initial velocity is 50 kilometers per hour, traveling west 60 degrees north. The truck's final velocity is 80 kilometers per hour, traveling east 60 degrees north. Calculate the truck's average acceleration in kilometers per hour squared. First, we'll look at what information we are given. Time is given as 15 minutes or a quarter of an hour. The initial velocity is 50 kilometers per hour, traveling at west 60 degrees north, and the final velocity is 80 kilometers per hour, traveling east 60 degrees north. We can draw the velocity vectors in order to visualize them. We know from the question that we want to find the average acceleration over this time period. Average acceleration is equal to the change in velocity divided by the change in time. Since time is given by the question, we have to find the change in velocity. Change in velocity is equal to the difference between two vectors, or the vector addition of the positive final velocity and negative initial velocity. To find the change in velocity, we can use the component method. This entails finding the y and x components separately from each other using the sine and cosine ratios for right-angled triangles, respectively. Finding the x and y components is the first step. From the diagrams that we drew, we now know that the y component of the initial velocity is 50 sine 60, while the x component of the final velocity is negative 50 cos 60. Note that the quadrant that the velocity vector is in does not allow for the cosine ratio to be positive, therefore making this x component negative. For the final velocity vector, the y component is 80 sine 60, while the x component is 80 cos 60. Now we have to subtract the x component of the final and initial velocity vectors and the y component of the final and initial velocity vectors. You can consider this as vector addition of a positive final velocity vector and of a negative initial velocity vector. We take north and east as positive, obtaining a final value of 65 kilometers per hour east for the x component and 25.9087611 kilometers per hour north for the y component. Now we can use the Pythagorean theorem to find the magnitude of the resultant velocity or change in velocity. After taking the square root of the sum of the square of the x and the square of the y components, the resultant velocity's magnitude is 70 kilometers per hour. However, we must still find the direction of the velocity. To do this, we can use the tangent ratio of the opposite over adjacent, or the y component of the resultant velocity divided by the x component of the resultant velocity. After taking the inverse tan of this ratio, the final angle, or theta, between the eastern direction and velocity vector is 21.8 degrees. Now that we have the resultant velocity, or the change in velocity, we can now import our values into the equation for average acceleration. After inputting our values, the resulting acceleration is 280 kilometers per hour squared while traveling in the direction east 21.8 degrees north.